This is another type of question. How many platters are required for 40 gigabyte disk if there are 1024 bytes per sector, 2048 sector per track, 4096 tracks per platter? Okay, so all these details are given. So now I want to know uh, how many platters are required for these many disks. So the disk is going to have this much capacity. So do I need to have one platter or two platter or three platter? How many platters I need it? Okay. The same way you do it, you need to find the capacity of one platter. Okay. So I mentioned in the previous example, if you want to know the capacity of one platter, you need to multiply the number of tracks, number of sectors, bytes per sector. Okay, number of tracks. Here it is, 4096. Number of sectors per track, 2048. A number of bytes per sector, 1024. So when it's all in bytes. Okay, when you multiply all those things, you will get a big number. So let me. Actually, you are getting these many bytes. This is the capacity of one platter in bytes. One in gigabyte, because the question is in gigabyte. So it's better to have in gigabyte. So convert into gigabyte. I told you need to divide by 1024 3 times. Then you will get the answer. So when I divide, I get 8 gigabyte. I didn't do it in the paper. I think you can try it in paper. So you need to divide by 1024 3 times. If you divide by one time, you get it in kilo. If you divide a second time, you get it in mega. When you divide by third time, you get it in gigabyte. Okay. So this is the capacity of one platter. But they want to have 40 kilobyte disk. Okay. So how many platters I need? Do you get the idea? So for example, you need to divide So you need to divide 40 divided by 8, you get 5. See, one platter it takes 8 kilobyte. I need 40 gigabytes. One platter is taking 8 gigabyte. So for 40, you divide by 8, you get 5. So that is the number of platters needed. Is equivalent to 5 platters. If you want to understand how do I divide, just you need to have an idea. Just see, 8 gigabyte can be stored in one platter. Can you get the idea? 8 gigabytes can be stored in one platter. So 40 gigabytes can be stored in how many platters? So you divide 40 by 80, you get 5. So that is the 5 platter. Can you get the idea? So this way, 8 gigabyte needs one platter. 40 gigabyte needs how many platter? So you cross multiply that. 40 divided by 8, you get 5. Okay, this is one type of question. And there is one other type of question we may have in hard disk. which is consider a magnetic disk drive with 8 surfaces. So this many track per surface, this many sector per track, and the sector size, this is the bytes per sector. The question gave you average seek time, track to track access time, and the rotations, how many rotations per minute. We discussed a few minutes ago this disk capacity, how to calculate, you know already. So I think you can try this one, disk capacity. And average rotational latency, we discussed that one few minutes ago. Okay, and this one, what is the okay, by the way, the one we discussed is rotational latency. In the previous example, we discussed rotational latency. For average rotational latency, you need to multiply half into rotational latency. You know how to calculate rotational latency. So multiply, you get them after you get the rotational latency, convert to milliseconds and then divide by 2. You get average rotational latency. Okay, it's not the same. Rotational latency is different, average rotational latency is different. Okay, and now average seek time. So when you are looking for, sorry, it's not a seek time, it's access time. When you say average access time, we studied it in the slides. There is a formula for access time. When you want to have access time, that's equivalent to seek time plus rotational latency. Seek time is given in the question 6 minutes per second. And your average rotational latency you calculate from this step. Okay, so average seek time, average rotational latency, you get average access time. So average seek time is given in the question, which is 6 millisecond. Average rotational latency you calculate from step 2, that number. So whatever number you get in millisecond. Okay. So this is the third question. How to calculate average access time, not the seek time, because average seek time is already given. This is a writing problem mistake. It's average access time. Fine. So this is about one type of question in hard disk. There is one type of question, you will have it in the RAID. This is for the RAID, not hard disk. This is redundant array of independent disk, topic in chapter 6, external memory. Let's assume that there is 4 drives and each drive is having 300 kilobyte per capacity. And the question is, what is the available data storage capacity for each of the RAID levels? We already studied there are many levels. 7 levels we studied. Level 2 is not given in this question. Okay, fine. Level 0, 1, 2 is not given. That uses the humming code. That's not given. Never mind. And 3, 4, 5, 6. Okay. So what is the idea? You are given 4 disks. So let's assume you have 4 disks. Each disk capacity is 300 gigabyte. So this is also 300. So what is the storage? Okay, what is the capacity of data storage or capacity of each RAID level? Okay, let's assume RAID 0. When you say RAID level 0, there is no duplication, there is no redundancy. Data is striped in all the 4 levels, all the 4 drives. So there are 4 drives and each drive capacity is 300. So the total capacity is 1200 gigabyte. Let's go into RAID 1. In RAID level, data is written in half of the disk, duplicated in half of the disk. So if you have 4, 2 plus 2. Data is written in 2 disks and duplicated in another 2 disks. Let's say if you have 2 drives, data is written one and duplicated in another, half and half. Okay, half and half for the RAID 1. So you originally data takes only 2 drives. This is the duplicated one. Okay, so this is the capacity of the data, 2 into 300, which is 600 GB. Okay, RAID 2 is not given in this, so let's go for RAID 3. Remember, RAID 3, 4, 5 are same. So when you do for RAID 3, you can kind of same. Okay, one separate drive is used for parity. So the remaining disks are used for the data. Okay, so you have 4, one will be used for parity. So data will be here in the 3 disk. So 3 times 300, which is 900 gigabyte. Same for the RAID 4, same for the RAID 5. It's the same. In RAID 4 also, one drive is used for the parity and the rest of the drive are used for the data. Okay, even only the difference is it's synchronized. Read-write head is synchronized with the disk. Here it is not synchronized, and this one parity is distributed across the disk using round-robin technique. So that's the difference. Okay, and RAID 6. Let's see the RAID 6. In RAID 6, 2 disks will be used for the parity. There is 2 parity bits. Okay, so among the drives, 2 drives will be used for parity and the remaining 2 for the data. So 2 into 300, which is equivalent to 600 GB. So problem solving question for RAID will come like that. How does it comes? You will be given some data and based on that you will be asked for RAID 0, 1, 2, 3. You have to remember the idea. Like how much is the capacity for RAID 0, 1, 2, 3, 4, 5 and 6. There are 7 levels, but RAID 2 is not asked in the question. Okay, remember the concept, then you can able to easily solve this question. So this is about problems for RAID. Okay, so that's it for the problem solving for chapter 6. So thank you.